second. Okay. Now let me share a screen with you. In your email, I sent you these worksheets. So see if you can download them. Now, usually where students are the most are word problems. So today we're going to spend a lot of time on word problems. And then next week we're going to work on percent word problems. And then we'll do some other things. And then we'll have about a lecture and a half available for you to ask questions on particular topics that you are uncomfortable with. And if nobody has any particular issue they want to talk about, we usually come back to word problems. Now, the first thing I want us to look at are these TEAS, metric conversions. So if we look at this English to metric unit worksheet, okay, so if we look up here, English to metric unit worksheet 1, we see how it asks you to convert from ounces to grams. So ounces is English units, and grams is metric units. Now, we look at some of these like miles per hour and knots. Do I need to know that? As a nurse, you don't need to know. That's not going to show up on the test. So the question is, which one of these do I need to know how to do? So in one of the old TEAS study guides, they had a list of what conversions they wanted you to learn. Okay. So I copied that, and that's in this TEAS unit conversion table right here. Let me show you. So the file that I sent you is a TEAS unit conversion table. It's also, these are all loaded in the My Haiku also. So you can also download it from there also. Okay. So the key is this. Whenever I go from an English measurement to a metric measurement, I go through these conversions over here. Now, even though 1 yard is a little bit smaller than 1 meter, on the TEAS, what they want you to do is say 1 yard is equal to 1 meter. Same thing with volume. You want to convert all of your English measurements into quarts. And even though a quart is a little bit less than a liter, they go ahead and say, what you want to do is convert, is say 1 quart is equal to 1 liter. They allow you to make that approximation. In fact, the multiple choice answer will probably assume that. And then for weight, the one that you usually use is 2.2 pounds is roughly equal to 1 kilogram. Now you're going to have to memorize this. And the deal is that once you become a nurse anyways, the very first few weeks, they're going to give you a big sheet of things to memorize. Every one of these units are on that big sheet of units, and they're going to give you a test on these units right within the first few weeks of nursing school. So they already expect you to know it walking into the program. So if I were you, I would learn it. Okay. Now, let's do some of these. Okay. So let's work on, let's remember that when we want to transition from yards to meters, right? We want to remember that 1 yard is equal to 1 meter, 1 quart is equal to 1 liter, and 2.2 pounds is equal to 1 kilogram. Those are how we transition. Okay. Now, let's do something a little familiar. Let's do something like, let's convert, before we go from English to metric, let's try doing something that we're more familiar with. Let's say to convert 2 yards to inches. Now, in these, in the conversion chart, you see these things that look like 1 yard is equal to 3 feet. And you have let me make sure I'm recording this. Oh shoot, yeah, I am recording this. I have 1 yard is equal to 3 feet, and I have 1 foot is equal to 12 inches. Okay. Now, you can use this one of 2 ways. You can say 2 yards. Now, to remember, now, to remember whether I multiply by 3 or divide by 3, what you want to do is have the yards on the bottom, feet on top. So 1 yard is equal to 3 feet. Now, the reason why you're doing that is, for example, when I have something like 6 over 2, I'm allowed to do a division where I go 6 divided by 2 is 3. In the same way here, the units will cancel each other out, and then you'll end up with 6 feet. Like that. Now, once I get to 6 feet, I want to do the same thing. And I want to say, I need to have feet on the bottom. So I know that 1 foot is on the bottom. And then I have 12 inches on top. These 2 will cancel. And then this is the unit that's left. So now I have 72 inches. Now, if you have questions, just like always, if you have questions, just interrupt me and I'll stop and I'll explain it to you. Okay. So this right here and this right here, that's this unit that's left over. So that's what we have at the end. Now, what some people do is they don't actually write the 6 feet. They'll go all the way across. They'll go 2 yards times 3 feet over 1 yard times 12 inches over 1 foot. And the reason why they did this is because this cancels this cancels this, and this is the unit that I have left over. So my answer is 2 times 3 times 12 is 72 inches. Okay, so let me give everyone a minute to copy. And I know many students will feel a little overwhelmed by memorizing this chart. You're going to have to memorize the chart anyways to be a nurse. So I would recommend just making flashcards and just doing it. Does anyone need any extra time to copy? Okay. So let's go the other direction. In this one, we went big to small. Let's go small to big. So let's ask ourselves 100 inches, convert 100 inches to, let's make it yards. Okay. So start with 100 inches. And remember that whatever you multiply it with, the inches has to be on the bottom because this and this cancel. So let's look at this. We know that 12 inches is equal to 1 foot. And we know that the 12 goes on the bottom because this inch and that inch need to cancel each other out. So these now cancel each other out. And now we have feet, right? 100 divided by 12 tells me how many feet we have. So now I've got to get rid of feet. I know 3 feet is 1 yard. So this foot and this foot will cancel each other out. So now I have 100 divided by 12 divided by 3 equals 2.7. I get 7, 7, it goes on forever, but we'll call that 2.7. We'll just round it at some point, yards. So the key is this, is that a lot of times people get caught up on, well, if it's the foot on the left side, does that mean the foot goes on the top or the bottom? And that's really not what determines what goes on the top and the bottom. Over here, we see we put the 1 foot, 12 inches. We put the foot on the bottom, 12 inches on top. And over here, you can see that we put the foot on the top, 12 inches on the bottom. What determines whether you're doing a division or multiply is that I need this to cancel out with that. They need to be the same. So if I have inches on top here, then when I'm using this conversion, the inches is going to be on the bottom. Over here, if I'm trying to get rid of the feet, this feet will be on the bottom, the inches will be on the top. Okay. So if you have something like this, we can use it either as 1 foot over 12 inches, or we can use it as 12 inches over 1 foot. Okay, so let me give you one to try on your own. So um, let's do English volume. So let's convert let's say how many cups are in a gallon. So let's convert 1 gallon to cups. Okay. So go ahead and look at this conversion chart. Let's see if you can do it. Right, start with gallons. You're using these over here. These over here. So we have 1 gallon is times. So 1 gallon is 4 quarts. And we can see that we got rid of gallons and now we have quarts. And that 1 quart is 2 pints. And that 1 pint is equal to 2 cups. Yeah. So that looks like 16 cups. Okay. Now let's start going from English units, and then let's go to metric units. So I want to know how many. So let's say 500 gallons. So let's convert 500 gallons to kiloliter. So go from gallons to liter we said 2 quarts, and then we said a quart is equal to a liter, and then go from a liter to kiloliters. Okay, let's see if you can do that. Right, go gallons to quarts, and then quarts are automatically equal to liters. and then go from liters to kiloliters. So let's see if we can do it. We have 1 gallon, and we know that 1 gallon is 4 quarts. And we know that 1 quart is equal to 1 liter. And we know that, so that's 1 liter here is 1,000 kiloliters. Oh, I'm sorry, I have 500 gallons. Is that right? 500 gallons. I feel like I did something wrong. Quart. Huh. That looks right. I feel like I have something upside down. 500 gallons. 1 gallon is 4 quarts. Then 1 quart is 1 liter. And 1 liter is, no, I guess I did. So this is equal to, looks like 2,000 times 1,000. I could swear it should be a division though. Okay, I got 2 million. But I don't have a lot of confidence in it. Let me let's do another one. And while you're doing another one, let me retake a look at this because I feel like that's not quite right. But let me give you another one. Let's convert 36 feet to centimeters. So try that one. Let me relook at this one. I don't feel good about it. Oh, I see my mistake. Yeah, I am wrong. Okay, now I feel better. Let me make sure I am on Zoom. Okay, I read this wrong. I thought it was a division, and it is a division. I apologize. My mistake is that 1,000 liters is equal to 1 kilogram. Okay. That's an easy fix. So now I have 2,000 divided by 1,000, so that's 2 kiloliters. Now I feel better about this problem. Okay, so now this is correct here. Now go ahead and do this one. So for this one, we'll do feet to yards, and yards are equal to meters, and then go from meters to centimeters. Give that a shot. Let me give you the conversions. So let's give it a try. So we know that if I have 36 feet, we know that 3 feet is 1 yard. And we know that 1 yard is roughly 1 meter. And we know that 100 centimeters, is equal to 1 meter. And that should be equal to, let's take let me get my calculator. Uh, 1,200 centimeters. Okay, so we're going to move on from this, but we're probably going to get one of these on the TEAS. So the nice thing about this problem, even though it's a lot of work to memorize it, one, it's work that they're going to make you do in nursing school anyways. And then two, you're not going to be confused. They're going to ask you to convert something and you'll know like, oh, I know I'm supposed to convert it. There's no like confusion of what this problem is asking for. Okay. Now, let's look at, let's see. So let's look at, so what we're going to work on now is a bunch of different kinds of problems. So let's share screen. So if we look at this table of translate word problem. Table of translate word problem words. That's a tongue twister. We're going to now work on problems that sound like the sum of a number and 2 is the same as the same number minus 6, okay, where they verbally give you an equation and you have to be able to translate it into math and then solve for a variable. Okay. Now, I have this list here, and it breaks down what each word means. Okay. So just have this open somewhere where you can refer off of it. Now, let me write a problem on the board, and I'll give you a chance to copy it, right? Some time to copy it, so don't rush. And at any time, if you find like I have a hard time copying and understanding what you're saying, just stop me, and I'm more than glad to slow down. Okay. I'm also, if you're ever in a situation where you go, I really like to hear what he has to say and stop copying, feel free to, and I'll wait afterwards. Just tell me to stop, and I'll wait so you can copy what's on the board. Okay. So let's try this. The sum of a number of twice a number and 2 is the same as three times the difference of the same number and 4. Okay, so go ahead and copy that. Okay. So whenever we have a problem like this, again, this is nice, just like the unit conversion problems, because we don't have any confusion as to what they're trying to do. Okay. We know that they want us to convert this into an equation and then somehow solve that equation. So what we have to do is we have to translate. These are called translation problems. Now, step 1, look for the phrase that means equal. Now, a long time ago, MIT did this study where they gave people a word problem and they made it easy to read. And then they gave the other half the word problems, but they wrote the words so small that people could barely read it. So when they read it, they had to read it very slow. Now, they found, strangely, that when the smaller they made the font and the more difficult it was to actually read the problem, the better the people did. And they theorized it's because you're reading the problem slow. And when you read the problem slow, you're able to see the different parts of it. Whereas if I was to look at this and go, the sum of twice a number and 2 is the same as 3 times the difference of the same number and 4, it makes my brain explode. There's just too much there. So what we want to do is we want to simplify this into 2 pieces. So if I know that at the end of the day, I'm going to get something, something, something equal to something, 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 let's first find that equal sign so that we can look at this and look at this separately. Okay. So in this problem, same as is the same thing as equal. So now we've divided this problem into 2 pieces. This piece here and this piece there. Okay. So now let's work on each part separately. Okay. Step 2. Step 1. Step 2. Look for the words than or from if you see them, reverse the order of the operators. So first copy that, it's a mouthful, and then I'll give you a few examples. So for example, if we do something like 5 less 2 or 5 subtract 2, these are equal to 5 minus 2. You see how we kept the same order? The 5 is first, the 2 is second, the 5 is first, the 2 is second. Now, if I say 5 less than 2, or 5 subtracted from 2, we now have the reverse order. This is now 2 minus 5. Now, we really only care about this for subtraction or division. The reason why is because if I have 5 minus 2, that is not equal to 2 minus 5. In the same way as 6 divided by 2 is not the same as 2 divided by 6. However, if we have something like 5 multiply, 5 more than 2, technically we should reverse the order. But let's say you missed it. Just say like, oh, I didn't notice the than. You get 7 on both of these. So if you miss that, it's okay, you'll still get the same answer. So you really want to be careful when you're looking at subtraction or division. With multiplication and addition, you can mess that up and it's not going to harm you at all. Okay. Now, in this question, I wanted to make it a little bit easier for the first one we did. So I did not put any thans or from. I'll put that in the next one. Okay. Let me give people a chance to copy if they want to copy. Okay, now the steps I'm giving you, right, what I'm telling you, this will work 95% of the time, maybe even 98% of the time. So on these exams, this usually works. On the exam and on any of your math homework. Once in a while, once in a long, long while, I'll find a math textbook where one problem at the very end will not fit these rules because they went out of their way to make something that only like a native English speaker would understand. So there are rare choices, but you've got to really work hard to make it happen for these rules not to work. So these rules work most of the time, will probably work on your TEAS, but don't bet your life on it because, you know, English is an amalgam of many different languages. So you can twist yourselves to make this not work. Okay. But on your TEAS, in general, it should work. Okay. All right, step 3. Do the last operator first. Just copy that, and I'll explain to you what that means in a second. Okay. Now, let's go through our steps. Look for the phrase that means equal. We got that. Look for the words than or from. They are not here. Now, when I look at this, right, just this first half, the sum of twice a number and 2, there are 2 operations going on here. Sum means plus, and twice means times 2. Okay. So the question is, which one do I do first? Do I multiply first, or do I add first? And the answer is always read this thing backwards. You're going to multiply first, and then you're going to sum. Okay. So when we do this one, we'll get, right? We're going to twice the number first. So think of it like this. 2x, and then we're going to sum 2 with it. Okay. And then we have that equal. And then we're going to just do the same thing here. Over here, I have 3 times. And over here, I have a difference, which means subtraction. So the question is, what do I do first? Do I multiply first or do I do a subtraction first? What you want to do is the last one. You do the last one first. So I always read it from the back and go, what do I hit? I hit that minus first. So I'm doing this one first. Okay. So that means I'm doing the difference of x minus 4. I'm keeping the same order because it does not say from and it does not say then. And then what I'm doing is I'm 3 times it. Okay. So there's 2 things that you'll see. Either you'll multiply the variable first and then add or subtract something, or you will add or subtract something to the variable and then multiply the whole thing by distributing. And then I'm going to subtract 2x plus 12. And I get 14 is equal to x. And then I'm done. So let's try another one. So we'll say so go ahead, do that one. So first find the equal. So here's my equal sign. So I have a minus and a times 2. But remember that this is a than. Okay. So figure out what you're going to do first. Are you going to do a times 2, or are you going to do the subtraction first? And then because we have a than, we have to flip the operation. So we're going to go backwards when we read this. Okay, so we have 2x. Right? So let's think about it. Okay, I have 5 and I have 2x. Right? That's the order. That's the order that's written. But the Zan says reverse the order. So normally I have 5, 2x, and then we're going to reverse the order. So I'm going to get 2x minus 5 is equal to. Okay. So the 5 came first, the 2x came second, and then we're going to flip it. Now do the second part. Do the same thing. Find the operators. Check if there's a from or a than, and do the last one. You do that one first. So you have a subtraction here, and you have a times here. Now remember, you're going to do the second part first. So we do this part first. Now notice that there's no than, there's no from. We're going to keep the same order. That, right? So you get 2x minus 5 is equal to 4x minus 12. And then we'll end up getting 2x is equal to, if I add 12 to both sides, I get 7. So I get x is equal to 7 divided by 2. Okay. Let's do 2 more of these, just to get you in the rhythm of it. Okay, then I have a whole worksheet of these. So while you're copying that, I'm going to bring up a new problem up on top. Let's see. So go ahead, copy that, give that a shot. First, look for the phrase that means equal. So first work for the find the word that means equal. And then here's the from. Now work your way down. If you're wondering what quotient means division. So this is a times, this is a subtraction, and we're going to go backwards. Okay, so we're going to say over here a number subtracted from 2. So let's do this one. But remember that we're doing reverse order. So while this order is x minus 2, you're going to go 2 minus x. And what are we doing to 2 minus x? We are 4 times it. Now, on the bottom, we have a plus and a divide. So when we read from the right, we hit that divide first. So we're going to do this. Okay. So you have 8 minus 4x equal to 5 times 3. 8 minus 4x is equal to 15. So I'm going to subtract 8 from both sides. And I'll get minus 4x is equal to 7. X is equal to 7 divided by minus 4. Let me give everyone a chance to copy this. Okay, now, something we have to be careful about. If there are commas, so I should do 2 words. There are commas. Put parenthesis around them. Okay. Now, this is the part where English sucks. Okay. So in all of these problems I've given you, there have been no commas. But if there's a comma, that sort of supersedes what we've been doing. So for example, if I have 4 times a number subtracted from 4, and we'll put the comma here. And then I'll write another one where we'll put the comma over here. 4 times a number subtracted from 4. And then we'll put the comma here. Okay. Now, when there's no comma, the pause is at the end. 4 times a number, pause. Oh, subtracted from. Oh, I'm sorry. Oh, I want to copy that. Take that back. When there's no comma, I take that back. When there's no comma, we do this one. Okay. All right. 4 times, pause, a number subtracted from 4. A number subtracted from 2. So when we go 4 times, we stop, we infer that these two things are together. 4 times 2 minus x. Like that. Over here, this is 4 times a number, pause, which means that 4 times a number is together. 4 times a number, pause, these two are together. And we're going to subtract them from 2. Okay. Now, on your exam, I don't think you'll get a comma because then it'll make the problem a lot easier because you'll know that, oh, group these together because there's a little pause there. You could say it in your head 4 times, pause, a number subtracted from 2, that's together. Versus 4 times a number, that's together, because we then have a pause subtracted from 2. So they could have commas, but I'm assuming that on your exam they probably won't have commas. When you look at most algebra books, they may have 1 or 2 questions like this, and all the rest of the questions are like this. This is the most common way they give it because they want you to assume where the commas are. Okay. Does anyone have questions on that? Okay, so let me show you right here. So if you want to practice these problems, we have this translation, word problems. And if we go onto the haiku, so let me go into the haiku. All right, so we'll go myhaikuclass.com, and my login is Kawhi123, and this is 123123, and this is available to anybody in the world who watches this YouTube. Just doesn't have to just be people in my class. Go to nursing TEAS. So let's see, under word problems, you'll see this Gay 3.4 word problems. Martin Gay is the name of the author. Okay, so these will have word problems, and we also have this 115 XYZ translation word problems. This is a really good one also. This is the one that I've created for my old exams. Let me show that one to you. Now this one's going to have a mix of things. A lot of percent stuff, But I also have, I think, mixed in here are translation problems. I think they're more on the bottom. Let me take a look. Yeah. So like over here. So these will try to trick you in the same way that I've tried to trick you today. More here, more here. So more around the end, I have these little translation problems. And then all the work is done also. So if you want to look at something where you go, I don't see the work, um, here's one where the work is actually shown. Okay, does anyone have questions? Okay, if no one has questions, let's take a 10-minute break and then we'll come back and we'll bang out a different type of word problem. Okay? Thanks you guys for hanging in there. Okay, let's get back to it. Okay, so let's see what we're working on next. TEAS week 6. That's our second week. Okay, let's work on ratio problems. Now, ratio is something that you've intuitively done and not necessarily known that you called it a ratio. Okay. Now, let's say that this is ratios. So let's say it's Halloween. Okay, you have kids coming over for a party. So let's say for every one kid, or sorry, for 5 kids, you bought 50 pieces of candy. Okay. And then you would ask yourself, well, how much did each kid get? Well, you could say one kid got 5 candies. Right? You just treat it like a fraction. And then you go, well, what if there were 10 kids? How many candies would I need to get? Well, you go, if there's 10 kids, I need 100 candies. The way I got 100 is I multiplied this by 2 and multiplied that by 2, and right? And I got that. Now, each one of these, 1 out of 10. Each one of these will simplify to 10 over 1. Okay. Now, we could have also written it like this: 50, 5, 10, 1, and 100, 10. The first number is the numerator. The second number is the denominator. So a typical question would be something like convert so go ahead, convert that to a fraction. That's the numerator, that's the denominator. The key that you have to remember is that you have to simplify it afterwards, because you simplify all of your fractions. So this one will turn into 2 over 12, and then we have to remember to simplify. Okay? And this one does show up, so you want to make sure you know what this means, could be able to convert it and just be able to simplify that fraction. Okay, now, so let's look at some ratio word problems in a classroom. There are 2 boys for every 3 girls. So this gives me the fraction 2 boys over 3 girls. Okay. So that's my basic information about my classroom. Now if I write, if there are 32, I'm sorry, yeah, girls, how many boys are there? Round to the nearest boy. Give everyone a chance to copy that. I'll do that for you. So we have this first statement here. For every 2 boys, there are 3 girls. And then we have the second statement here that for every 32 girls, we don't know how many boys there are. Now, the easiest way to solve this is what we call cross multiplication. We can multiply this with this and this with this. So I don't have to bring the 3 up here. I can just leave it here. So I end up with 2 times 32 divided by 3 boys. Let's see what that is. So 64 divided by 3 is 2 point. So if I round it to the nearest boy, is 21 boys. So let's give you one to try. Let's take a picture of this. Okay, now let's look at in a cake recipe calls for 2½ cups of sugar for every 3 cups of flour. How much sugar does a 5-cup cake require? Okay. So first make your first fraction for sugar over flours. So you go 2½ cups of sugar. Just say sugar. 3 cups of flour. Okay. Oh, I'm sorry. 5 cups of flour. Sorry about that. I should tell you which of the 5 cups is. So go ahead and put the 5 cups with the flour, and then go ahead and cross multiply. Okay. We have 5 here. We have sugar, we have X. So this 5 goes up there. Now, because you're using a calculator, don't work in fractions. Just convert that to a decimal. Right? Make your life a little bit easier. So let me find my calculator after I made my life easier. So I have 2.5 times 5 divided by 3. So I get 4.1666. So at some point, they'll probably tell you to round it. I'm just going to round it there. Okay. So let's take a picture of this. Now let's go back to this setup. If there are 17 boys how many total? Well, we'll make it 18. How many total students are there? Try doing that properly. Now we're not asking for how many girls, but finding out how many girls there are would help us know how many total students there are. Now, even though this question doesn't ask for how many girls there are, if we find out how many girls there are, we can add them to the number of boys, and that'll tell us how many total total students there are. Right? So you have the 2 boys over 3 girls. You have 18 boys. You have X girls. So go ahead and solve that problem. Okay. Now remember, you can multiply this up there and multiply that up there. Okay, so you have 2x is equal to 3 times 18. 2x is equal to 54. So x is equal to 27. And let's remember what our units are, girls. So total students is equal to 18 boys plus 27 girls. Ooh, that's terrible. That's unreadable. So it's at 80, 35, 45. So go ahead, copy that. Does anyone need extra time to copy? Or are you okay for me to share screen? So let's take a look at this. Let's share screen back into here. Now, when studying ratio problems, I have this one here. That's from a textbook. It's pretty good, but the problems are very similar. I really like, if you're going to only work on one worksheet, for you to work on this ratio word problems. This is also on the haiku. So let's click into here. The reason why I like this one is that this has a broader selection of different kinds of ratio problems. So I think the answers are on the bottom here. Yeah, actually, the answers here are on the bottom. So let's try doing some, okay, because each one of these problems is slightly different. Okay, so let's look at problem 3 over here. 3 over here. So try doing 3. Okay. So if you're having trouble with this, the trouble probably is, which class has a higher ratio of tall to short students? So the first question is, what the heck does that mean? So understand that whenever we are looking at a ratio, something to something, it's always numerator over denominator. So over here, when they say tall to short, what we're looking at in terms of our ratio is tall over short. Hi, Minnie. I'm glad you found this. I'm sorry I didn't see your email until right when I sent it. But I taped this, and whatever you miss, I'm just going to put on YouTube, and I'll send you the link. Now, when we look at this, we want to look at the, so remember that the first one is tall, second one is short. So again, we want to look at this tall to short. So in Jack's class, we have 18 over 10 versus in Michael's class, we have 54 versus 30. And we want to know which one is bigger. Now, the easiest way to convert them is to compare them, is to convert them into decimals. So if I have 18 divided by 10, then that is, give me 1 second, make this look better. It's over here this way. Okay. Then we're looking at 1.8 versus, and then 54 divided by 30 is 1.8. So the conclusion is they have the same tall to short ratio. Now go ahead and try doing number 6.
Professor.
Yes, how can I help you?
I have question. From where we have to do number 6? I didn't find the also number 3 too.
Oh, okay. Let me show you. Okay, give me 1 second. So in your email, I emailed you a bunch of files today, and then let me show you where it is. Okay, it's going to be.
Write? Okay.
It's going to be right here. Do you see right here? Ratio word problems.
Yeah, I opened my high kawaii, but I didn't find there. Ratio problem.
Oh, okay.
Okay, ratio word problems. Okay, I find it.
You find it? Okay, great. Thank you. Thanks for letting me know too.
Yeah, thank you so much. Number 6, yes, you said.
Yes.
Okay, thank you.
Okay. Now, for some of you, you're just thinking, can I just multiply this by 7? And the answer is yes, right? If 5 cans is 340 and I'm buying 7 times more, you can just multiply it by 7. So don't get so caught up that you necessarily have to use my notation. Many of you have been using ratios all the time. You just never really thought about it as like per se a ratio. You just use your intuition and say, hey, if I buy 7 times more, I just multiply by 7. The answer is yes. So on these questions, just because it's on a test and it's just because it's on a test doesn't mean you just can't go multiply by 7. And the answer is yep, that works fine. Okay. So let's do this one. Okay. Let's look at number 4. And again, this one you can just use your intuition. $1.44 divided by 3 cents is 0.48. And 250 divided by 5 is equal to 0.50. So quick mark is a better buy. Okay, so we're just about up to 10 o'clock. So let me give everyone a break, and I will upload this on YouTube and send you the link. So if you want to watch the same lecture and just be able to sort of watch it slow and be able to pause it, that's great. If you have questions, please don't hesitate to send them to me. Next week, we're going to work on percents. And if you have topics that you go, hey, I'd love to see fractions, or I'd love to see, like, don't wait for me to do it and go, oh yeah, that matches, and oh wait, you didn't cover this. Early on in the process, email me what you want. I'll find some worksheets and we'll work on specifically what you think you are weak on. Okay. So thanks everyone. Have a good weekend.
Thank you, Professor.
Professor, bye.
Thank you. Bye.
Bye-bye.